Finally, the day has arrived. No, I'm not talking about finding the love of your life. I'm talking about the day when you wrote your first container. So now you thought, all right, hard part is done. I'm going to take this container and run it in AWS. But then you get intimidated. There are so many options on AWS to run your precious container. Amazon Elastic Kubernetes Service or EKS, Amazon Elastic Container Service or ECS, AWS Fargate, AWS Elastic Beanstalk, Amazon Lightsail, and another new service for which there is no icon yet, AWS App Runner. So obviously you get very confused because all this service wants your container. So which service should you choose? Let's find out. Let's start with the powerhouse in the room, Elastic Kubernetes Service or EKS. So Elastic Kubernetes Service is based on Kubernetes, which is open source, and that gives you unmatched flexibility. What that means is you need to install and maintain the packages for almost everything. For example, if you want to scale your container, you need to install Metric Server to monitor CPU and memory utilization, and then use HPA or Horizontal Pod Autoscaler. So this is a Kubernetes construct, not a cloud construct. Similarly, for logging, you need to install FluentD and FluentBit to send your logs to CloudWatch and other options. For monitoring, you need to install Prometheus and Grafana. For security, you need to learn RBAC, network policy, IRSA, etc. So on top of learning AWS concepts, you need to learn Kubernetes concepts as well. There are some AWS integration with EKS, such as Application Load Balancer, Network Load Balancer, and the cost of EKS is the fixed cost of control plane, which comes around $72 per month, plus the worker plane cost, which is the cost of the EC2s running your workload. So what is the con of using EKS? There is steep learning curve and you have to maintain open source add-ons. The pro is Kubernetes is cloud agnostic, so you can move your workload very easily from one cloud to another cloud. And since it is open source, there are lots of samples and examples for you to copy paste and learn from. Mostly copy paste. So now moving on to Amazon Elastic Container Service or Amazon ECS. ECS is AWS specific service, so it gives you powerful simplicity. AWS provides the features out of the box. For example, where we saw for scaling, logging, monitoring, security, for EKS you need to learn Kubernetes constructs. For scaling, for ECS, you can utilize AWS autoscaling. So you learned autoscaling when you learned about EC2, the concepts are exactly the same. For logging, ECS integrates with CloudWatch out of the box. You do not need to do anything extra or you do not need to install any third-party software. Similarly, for monitoring, ECS integrates with CloudWatch out of the box, and for security, you can utilize similar AWS constructs such as security group, network access control lists, and VPC constructs. ECS has better AWS integration, such as it supports running your workload on Spot instances or Fargate Spot. ECS integrates with API Gateway, and the capacity provider of ECS makes your application highly available really easily, etc. The cost for ECS is just the worker plane cost. The control plane is free of charge. So what is the cons of running your container in Elastic Container Service? Well, it is cloud specific. The pros is you get to onboard your application faster, and also it is cheaper because you do not pay for control plane and there is out of the box support for a lot of the features so that you don't spend time installing, building, and maintaining. However, some people think even though ECS and EKS can run your container, they are very different. That's not entirely true. There are some similarities between ECS and EKS. So let's take a look. The concepts are interchangeable, such as the pod in Elastic Kubernetes Service is similar to a task in ECS. The replica set and service in Kubernetes is similar to service in ECS. The horizontal pod autoscaler is similar to task autoscaler in ECS, and cluster autoscaler in Kubernetes is capacity provider scaling in ECS. For security, some of the components are exactly same. Both with ECS and EKS, you need to do static and dynamic scanning, AMI hardening, and OPA or Open Policy Agent concepts are also similar. And both works with EFS or Elastic File System. And at the end of the day, both are running the exactly same application container. You do not need to change the container if you want to move from ECS to EKS or vice versa. So as you can see, even if you learn EKS or ECS, you can quickly pick up the concept of the other one. So how about AWS Fargate? People think AWS Fargate is special. Not really, because Fargate still belongs to either ECS or EKS. So ECS or EKS concepts still apply. So if you are running a Fargate, let's say in Elastic Kubernetes Service, basically all you need to worry about is the pod. And if you are running a Fargate in Elastic Container Service, all you need to worry about is the task. There is no EC2 or underlying application machine image or AMI to manage, which saves you time and lets you focus on the actual coding. However, there are some limitations or considerations you need to understand with Fargate. You can have up to maximum 4 virtual CPU and 30 GB of RAM. If you run your container in EC2 as part of EKS or ECS, you can literally have unlimited amount of virtual CPU and unlimited amount of RAM. Well, it is not unlimited, but it's way higher than 4 vCPU and 30 GB of RAM. There is also no GPU support for Fargate, and there is no Windows container currently. If you do want to run your Windows container, you can convert your code to .NET Core and run it in Linux container. For Fargate, there is no daemon set and no privilege mode. So if you are running a software or an agent which relies on daemon set, that means you need to either install the agent that supports running it as a sidecar. And no privilege mode is actually a good thing. So privilege escalation attacks is not possible in Fargate. The cost of Fargate is based on the CPU and the memory of the task or the pod and the duration of the Fargate. Even for Fargate, you can run the same application container without any change as you are running in EKS or ECS EC2 worker nodes. So as you can see, EKS Fargate has some differences, but it's not really that different. So now let's move on to the other side, Elastic Beanstalk. So ECS, EKS, and AWS Fargate within these two services are controlled by an orchestrator, whereas Elastic Beanstalk does not have a container orchestrator. So what does this container orchestrator do? Think of this container orchestrator as the air traffic control, which has a higher level visibility of all your pods or the tasks. Since it has the visibility of the entire cluster, you can control that hey, this pod can go to this EC2, that pod should go to the other EC2, etc. What are some of the other features? It can control multiple pods, tasks in same EC2. So within a single EC2 worker node, you can run multiple pods or tasks. You can control which pod or task goes to which EC2. You can do granular scaling within a single EC2, as well as the scaling of the EC2 worker node. And other things it can enable is using service mesh, replica, pod disruption budget, making it highly available, etc. But what if you do not care about any of these advanced features? You just want a simple life, you just want to run your container, and that's about it. That's where the other options come in. Elastic Beanstalk, Amazon Lightsail, and the new addition AWS App Runner. So let's look at AWS Elastic Beanstalk first. In Elastic Beanstalk, you can run only one container per EC2, and that is exposed with Application Load Balancer. Elastic Beanstalk works with private Elastic Container Repository, and it also works with public ECR as well. So you might be thinking, Raj, what a weird thing to mention. I assume everything should work with private container registry. Well, just hold on a minute. So moving forward, AWS Beanstalk does not have a serverless or Fargate option. Everything runs on EC2s. And Elastic Beanstalk scales based on the number of connections coming to the load balancer out of the box, and you can also make the EC2 scale based on the custom metrics. Elastic Beanstalk can work with Amazon EFS for storage. And since there is no serverless option and you are forced to run one big container in a single EC2, it can be cost ineffective. So what is one of the cons of running your container in Elastic Beanstalk? Well, there are no advanced container features. It runs your containers, exposes it with load balancer, but if tomorrow you need to use service mesh, segregation of workloads using different namespaces, a network policy to restrict traffic, creating different replicas of tasks or pods, etc., Elastic Beanstalk can do that for you. Pros, it is super easy to run your container. So now let's take a look at this Amazon Lightsail. For Lightsail, you run one container in this pseudo EC2, which is exposed with Application Load Balancer. So in the Lightsail console, you select this Lightsail node based on the RAM and vCPU that you need, and that's where your container runs on. Lightsail only works with public ECR or public container registry. It does not work with private ECR. Or you can use Lightsail's own registry known as Lightsail registry, where you have to save your Docker container in this special Lightsail registry. There is no serverless or Fargate option, and there is no auto scaling as well. You specify the number of pseudo EC2s and that's it. Even if the traffic goes up, the number of these Lightsail instances doesn't go up or down. It stays at that specific constant value that you specified. So beyond a certain traffic, your application will start returning errors. You can use EFS with Lightsail, but Lightsail runs in its own separate Lightsail VPC, so you need to peer to the regular VPC to use EFS. And since there is no auto scaling, and you need to say how many of these Lightsail pseudo EC2 node you want to run, the cost is fixed per month. This whole thing is kind of weird, isn't it? So the con is kind of everything. Why would you learn all these Lightsail concepts such as Lightsail registry, Lightsail VPC, Lightsail node, even if you cannot scale anything and you cannot really reuse this knowledge for any other AWS service. So the only pros here that I could think of is it's a fixed cost container service. So if you select the number of nodes, it will tell you the cost per month, so you know how much you are paying. And a note, even for ECS, EKS, Fargate, Elastic Beanstalk, you can control cost by specifying up to how much they are allowed to scale. And you can also create billing alarms for all the other services. Even before we jump into the recommendation section, let me just tell you, I highly recommend not to use Lightsail. All right, so now let's take a look at the new AWS service, AWS App Runner. With App Runner, you specify the amount of virtual CPU and memory to run your container, and it is exposed with Application Load Balancer. It works with private ECR as well, which is good. It can scale based on incoming connection. So whatever vCPU and memory you allocate, when the number of connection increases for the application load balancer beyond a certain point, it will just create another app runner instance with the same amount of vCPU and memory. Very similar to Elastic Beanstalk, where Elastic Beanstalk is scaling the EC2. With App Runner, it's scaling this App Runner node with a specific amount of CPU and memory. One advantage of AWS App Runner is it creates the code pipeline for you. App Runner is not attached to your VPC. So if you want your workload to be in private subnet of your VPC, then it won't work for you. And App Runner does not work with EFS. So what are some of the cons of AWS App Runner? As we see, some core features are lacking, such as not attached to VPC, no EFS support, etc. However, it is a new service and hopefully it evolves over time. What is the pro? It is super easy to run your container. All right, time has come to go over the recommendation or the verdict. So if you are just learning Docker container and want to test out the Docker container concepts without anything to do with running it on an orchestrator or in the cloud, just use your local laptop or desktop. If you don't want to use your local laptop or desktop, just use a small EC2 instance, install Docker in it, and then just run your Docker, or use Cloud9. You can code your container manifest files in Cloud9 and test out in the Cloud9 CLI. If you are running a simple application and you do not foresee any change of scope in future, then use Elastic Beanstalk if Elastic File System is required. Use App Runner if no storage is required. And last but not the least, if you are running an enterprise app or applications that will evolve in future, such as maybe it will increase in scale, maybe you need more security control, or maybe you need control knobs to control your traffic in a certain way, or maybe if you are preparing for an oncoming interview, and I know a lot of guys and girls who watch my videos, you are preparing for interview, then learn ECS or EKS. So for running your application, run it in ECS or EKS Fargate if possible. So I say possible because not everything is supported in Fargate as we saw. But running it in Fargate lets you not worry about the underlying EC2, no security patching of those nodes, no AMI. So it frees you from a lot of overhead. If it is not possible, run it on ECS or EKS with the EC2 worker mode. Remember that ECS offers powerful simplicity. So if your application needs to go fast to production and you don't have time to upskill your team to learn Kubernetes, also in case something goes wrong, you want AWS support to help you, then go with ECS because ECS uses all the AWS components. Else use EKS because EKS offers unmatched flexibility. Just a little plug, if you are interested in learning Kubernetes in detail along with Amazon EKS, Fargate, and DevOps, check out my course in Udemy. It is highest rated amongst all the EKS courses. It starts from very basic. You do not need to know container. It teaches you the container, and then it goes deep into all the EKS and Fargate and DevOps concepts. It also has some great reviews and student feedback. Also, if you found this video helpful, if you learned something new, please subscribe, click that like button, smash it if that's something you are into. Each like really helps YouTube algorithm. It suggests this video to new viewers. Alright guys and girls, that's it for this one. I'll see you in the next one. Bye.